Watching Over the Edge from Event Horizon with John Michael Gaudier.
And we're back with astronomer Christian Reddy. Now, even red dwarfs are not permanent. Even they will evolve into something else, which leads us into a conceptual star, I guess you would call it, that does not yet exist in the universe because there just hasn't been enough time. The blue dwarf. What is the process from which a star becomes a blue dwarf?
Well, the idea is that as a star is continuing to consume its hydrogen fuel, helium is building up, and helium being more dense, being heavier, that's going to squeeze the core down. So this core is going to compress. That's going to increase the pressure, which in turn will increase the temperature, the overall temperature of the star. So the star has to heat up over time. This is true of all stars. Our sun is doing it right now, but it's even going to be true of red dwarf stars, trillions of years from now. So as the star warms up, it really stops being a red dwarf and then becomes, well, we mentioned the term earlier about yellow dwarfs, but yeah, it could become essentially sun-like in its overall temperature. But if you have a red dwarf star that has enough mass, it will squeeze itself and become hot enough to actually surpass the sun's surface temperature. So the sun has a surface temperature of like 5,800 Kelvin. Now we're talking somewhere around 8,500 Kelvin. So this thing's really hot. I mean, we're talking about something with the surface temperature that is comparable to, say, Sirius, for example. We're talking about a blue dwarf star. So this thing gets very hot very quick, and so it can spend anywhere from a billion to several billion years burning as this blue dwarf. But everything, as you point out, everything is all that we're talking about here is purely hypothetical, or I should say theoretical, because they come as the result of analysis and applying what we know about stars today and extending it out further in time. And yet the universe is simply not old enough to have ever seen one of these things evolve. So this is kind of a very interesting type of star, something that doesn't exist, but we think should exist in the distant future. So the nice thing about blue dwarfs is that they're very hot, which means that their habitable zones, are now very far away. So now you have stars, or rather now you have planets that are, as you said earlier, they're at Earth-like distances from the red dwarfs, which means that they're free from tidal locking, and with billions of years of blue dwarfness, you could have a real Earth-like situation going on an Earth-like timescale.
Which again, should the human species survive that long, in whatever form we would be by that time, you could also colonize a blue dwarf, at least for a time, at least as long as it exists.
Well, I mean, when you have a blue dwarf, if it has a stable blue dwarf lifespan, about 5 billion years. Well, hey, you know what? The Earth has been around for 4.5 billion years, and that was enough time for us to show up. Now, that means that, you've got a real opportunity. If you let life evolve, there could be a full civilization evolving around a blue dwarf. Or if we migrate there, then we could enjoy billions of years of relative luxury around a blue dwarf.
Now, the physics strongly predicts the blue dwarfs, that this, just because of the physical process of how stars work, these things are eventually going to come into existence. When are we going to see the first blue dwarfs?
I think that would probably, assuming we're talking about a red dwarf star that formed around maybe the same time as our sun did, we probably aren't looking to see the first blue dwarf emerge for about another 7 to 8 trillion years from now, I think at the earliest. So we've got a little ways to go.
That's going to be an interesting time. When you go that far in the future, the universe is going to be so different. I mean, doing cosmology, for example, by that time, you may not even know that anything other than your local group of galaxies even exists. It's just too distant.
And the Milky Way will have long since merged with Andromeda. Maybe the entire local group, maybe you don't even know about your local group, because what used to be the local group is now just the galaxy you live in. Everything's merged together, and you can't see any other galaxies. They've all sailed over the cosmic horizon due to the expansion of the universe. So what are you left with?
And you wouldn't even know that things like a spiral galaxy ever existed, because when you start getting this mashup of galaxies merging, you lose the structure, and you have basically just an elliptical galaxy at that point, gigantic one.
But an ellipse of what exactly? Because by this point now, if you think about it, all of the solar type stars have all long since died. So you have a sky that is pretty much devoid of just about everything. I mean, the red dwarfs are all that remain in this time frame, and then those that have evolved onto blue dwarfs. So we can't even see Proxima Centauri with our unaided eyes. It's too faint, and yet it's only 4 light years away. Maybe if you're living somewhere in a cluster of red dwarfs, maybe you'll see some nearby stars. Otherwise, forget it. It's not going to happen. You're just going to see an empty black sky.
An empty black sky, which may never. I mean, imagine how that affects the civilization that may be arising at this time, because they wouldn't be able to do things like simple navigation using the stars, because there aren't any. So they may never decide to go and explore their own world. They may just think, we live on this island, on this planet, we don't know anything about it, and we have no way to navigate and see if there's anything else. So it changes the equations for entire civilizations that might arise that late in the universe's history.
They'd see their star rising in the morning, setting in the evening. If they're lucky enough to have a moon or two, they'll see those. Maybe they'll see the other. Well, I'm sure they'll see the other planets in their system. But yeah, that's it. That's kind of a shame.
I wonder if you could navigate using just moons, or your system's planets, or your star.
Yeah.
I don't know if that's enough.
I don't know either. I would imagine so, provided you really, really understand the motions of these planets well. But would they be able to figure it out? That's a really interesting question.
Yeah, it is. It's an interesting scenario anyway, where you just have a civilization that just never really does anything, because we are so dependent on astronomical data throughout our history. Whereas they, that someday that's not going to be available.
I mean, what happens if our descendants manage to make it, into that epoch, and they happen to visit a system with a civilization that's emerging around a red or a blue dwarf star? Well, maybe they could tell them, hey, there was once upon a time when the universe was a lot different. Only they wouldn't know it from their firsthand. They would have to somehow know. They would have to somehow have a record of the modern day universe, or the present day universe, and who knows if even that would happen.
Yeah, or they find something weird, like they find Voyager 2, which isn't going to exist by then, but somebody else's Voyager 2, and they're like, what is this and why, Or again, they make contact with somebody else that's been around since the beginning of the universe and shows them a photographic plate of stars, and just let them puzzle as to what exactly that is.
Clever enough to understand, could they figure out that's a star?
Yeah. Why are there so many?
Is there one star in the universe?
Now, what happens after the blue dwarf stage? What does it become?
It really just starts to cool down as a white dwarf by this point. Now we're back to a very familiar scenario that's going to happen to our sun and virtually any star up to about 8 solar masses or so, where you have this used to be the core of the star, and I guess in the case of the red dwarf, used to be the red dwarf, used to be then be the blue dwarf. Now it's just a ball of degenerate helium. It's no longer able to fuse. The star cannot squeeze itself hard enough to ignite that helium and carry on thermonuclear fusion. So yeah, it just starts to cool down very gradually. So it becomes a white dwarf star, and it will continue to be a white dwarf star for maybe several more billion years. So it's not like they just wink out in a short time frame. Although it is a fairly short time frame compared to their main sequence lifetimes, but we're talking on the order of like tens, maybe hundreds at most, billions of years as a white dwarf. But then after that, they cool down even more. and then their surface temperature once again returns to somewhere around maybe 3,000, 2,000 Kelvin, and it actually kind of starts to become its former self once again, or really more of a zombie of its former self. Because on the one hand, it's as cool, its surface temperature is once again as cool as it was when it was a thriving red dwarf. But on the other hand, it's just radiating heat away, and there's no convection, there's no thermonuclear fusion. It's just a solid lump of degenerate cooling helium. But even then, that red dwarf, or would it be a red dwarf? That very, very cool white dwarf, now turned red, cools down even farther, and then becomes something that's even more hypothetical, I guess, than a blue dwarf, and that is a black dwarf, right? Becomes something that just doesn't radiate anymore, or at least not at any wavelength that we can see. I mean, maybe if you held your hand up to it, it would have just some residual heat. But now we're talking about a star that you could easily touch and, walk around on, and you'd be just dancing on the crystallized sphere of degenerate helium.
So it's effectively the fate of the red dwarf is a helium cinder.
Yeah,
that
exactly.
just wanders the universe till the proton decays, or whatever the end of the universe might be, if there is one.
Right, exactly. If there's an end to the universe, or maybe the big rip comes along and rips that little thing apart. But yeah, that's it. That's what you have as a final end state. But I also think it's worth mentioning that, we're talking about something that is so far in the distant future that when these things die, they will more than likely be the last star to die. Like when the last red dwarf turns into a black dwarf, that's it as far as natural starlight in the universe is concerned. I'm not saying that there won't be any sources of energy for a hypothetical civilization to use, but it won't come from a star. They're going to have to figure some other way of getting it.
At that point, they may simply just decide to turn out the lights and fade. There's because I guess you would have energy sources, but even eventually then you start running low on that because you're just gobbling up any resources you have left in your lonely galaxy, and at that point, intergalactic travel probably is outright impossible. So you just
I think at the point you have to start thinking, all right, can we just skip this whole, can we just punch out of this universe entirely? Can we leap over to some other dimension, or catch another Big Bang or something like that, and go live in somewhere else? Because you're right, I don't think there's anything left in the universe to make a living on.
Which that's an interesting point. I mean, at that point, if we would happen to still be around, or some successor of us that's somehow related, could we do something like that? Could we create a new universe and actually start over, and get out of this one, or somehow? I mean, that's highly speculative, of course, but it is interesting to think about.
Yeah, maybe if we invent some way of expanding the quantum foam into a macro level and sailing through a wormhole and just funneling ourselves out of this universe and hope for the best. I don't know.
Yeah, well, one view of black holes is that it's just that simple. If you can figure out how to survive traversing the black hole, if they are indeed traversable, it may lead you into an entirely new universe. But then I guess you have to hope that it has the same ground rules as this one, or else your matter will just dissolve or something like that if you try to go through it.
Hopefully you got like a looking glass type of setup where you could look and say, oh, look, that one's it's close enough. Let's get to that one. And
right.
You're in another finely tuned universe.
Yeah, which is interesting. I mean, that brings up the the anthropic principle, where this universe, it just happens to be this way. So does that imply that there are many, many, many other universes that aren't this way, and that we in fact do live in some form of a multiverse? Either that, or our universe looks just really weird at that point. But if there isn't one,
there's an infinite number of universes. That means there should be an infinite number of universes that are just like this one as well, or
right.
Close enough that you can get by.
Yeah, absolutely. And God, infinite universes, that also brings in, ideas of parallel universes, where we're sitting here having this exact same conversation, but in just a slightly different form, somewhere out in the multiverse.
Yeah, exactly. In this other universe, I'm sipping coffee instead of tea. Something like
Right.
that.
Or you're interviewing me on your channel instead of the other way around.
I think that's an impossibility. I mean, I don't know. It's
Now, you're a YouTuber like I am, and your channel is Launchpad Astronomy,
Mhm.
and which is currently growing at breakneck speed. And what is it for people that want to go check out your channel? What is it that you do over there?
Well, I talk about all things astronomy, and that's something just because it's an outgrowth of my desire to just share this as stuff with as much people as I can. When I was going all the way back to the 80s, when I was working at Sproul Observatory, we used to have these open houses, and once a month, that was probably my favorite part of the job, was throwing the doors open to the public and showing people stuff through our telescopes. And I've never really lost that desire. When I worked on the Hubble Space Telescope, I used to go out and give talks, and now I teach astronomy at Towson University. I love sharing this stuff. So what I try to do at Launchpad Astronomy is just continue that general outreach, that hey, this is really cool, let's talk about the stuff. So it is a general astronomy channel. I think the universe is plenty big enough that there's never any shortage of topics to talk about. And even though there are some amazing channels here on YouTube, such as this one right here, which I really love, the universe is so big, there's room for many people to come on and talk about the stuff. So I pick stories and topics to talk about that I think would interest my viewers, might interest my students if they ever decide to watch one, and certainly interest me. So I like to talk about them there at Launchpad.
If you think about it, if the universe itself is infinite, or we live in an infinite multiverse, you cannot physically ever run out of topics to talk about.
Exactly. There's always something to talk about. And the good, even better, is that there's a lot of astronomers in the world doing a lot of astronomy. And we live in an age where you've got things like the Hubble Space Telescope, the Gaia satellite, the Chandra, Fermi, so many amazing observatories in space. And then you have even more observatories on the ground, Keck, Gemini, just to name two. Then you've got radio astronomy, and now we even have this next generation of these super telescopes that are coming online, which are just going to extend us even another order of magnitude. And I'm talking about things like the Large Synoptic Survey Telescope, the Giant Magellan Telescope, 30-meter telescope, and the Extremely Large Telescope. I mean, this is a good time to be doing astronomy, and also a great time to be talking about it.
I'm very cognizant of that we are living in a kind of golden age of space exploration and science, because we've done science long enough. We've got a pretty good handle on things, been around the block a little bit, but there's still plenty of stuff to discover. And then you see things like SpaceX, going into dramatically dropping launch costs and creating an environment where if Elon is successful, we'll have some kind of a Mars colony soon. So it really does seem like you're living in a golden age watching all this stuff unfold. And it's really different if you contrast it to, the early 2000s, where it just didn't seem this way. It seemed like things were kind of slowing down, but all of a sudden it's blossomed. And that's something I keep in my mind, that, be thankful you live at this exact time in history, because it's absolutely fascinating.
I agree. I forgot to mention my other TV influence, which I know is yours and is just about everybody's, and that's Carl Sagan's Cosmos from 1980.
Oh,
yes, and you're right. I mean, that came at a time where we were unfortunately kind of transitioning from, I guess, the first golden age of space exploration into kind of a, I don't want to call it a dark period, but it was a very dull period. And then the Hubble Space Telescope came around in the 1990s, and people got excited again. But then it kind of ebbed off a little bit. And I agree. I think now, thanks in no small part to SpaceX, people are starting to think about the future again. And as Neil deGrasse Tyson put it, people are starting to dream of tomorrow once again. So I think that's, if there's anything that I can do on my tiny little YouTube channel to help keep that ball rolling, I'm going to do everything I can to help that.
Yeah, that I share that philosophy wholeheartedly. If just some small part, even if you just inspire one kid to go become a scientist, you're successful, as a science presenter. And we sort of fill the role that Star Trek filled for us. It's now YouTube, and it's nice to see so many great science presenters on YouTube these days, and it really is a wonderful thing. That's another aspect of living in a golden age. We now live in a golden age of science communication too.
And that's this couldn't come at a better time, because there's so much science denial out there as well. And yeah, I mean, you really, unfortunately, it's just become as much of a pushback against an alarming anti-science trend.
Yes.
So it's kind of almost paradoxical, right? Like on the one hand, we have all this incredible stuff going on, and then we have people who deny climate change, people who insist that vaccines are dangerous,
flat Earth,
electric universe, goes on and on and on. So we're at a golden age, and yet there's also this huge fork in the road.
Mm-hmm. Yeah.
So if we can steer people to the right direction, then we're in good shape.
That was a bit of material that went over the edge. A bonus clip from a full episode of Event Horizon. New episodes every Thursday, so do be sure to hit subscribe. The full episode should be on your screen right about now.